So it says the area of a rectangle is 64 square feet. The length is twice the width. What are the dimensions of the rectangle? So best thing to do out of this is maybe draw yourself a little rectangle. I'll use my straight tools. Okay, so I know that if I were to find the area of this rectangle, the area is equal to length times width. You agree with that? That's an equation you've seen like once in your life. All right, so we'll call this length, we'll call this width. Seem okay so far? And then it says the length is twice the width. Well, if the width is x, then the length is going to be 2x. Okay? Now we want to just find the dimensions of the rectangle. Well, I'm going to replace my L and W with what I called with x and 2x. So I know the area is, because it was given to me as 64, 64 is equal to x times 2x. What's x times 2x this week? 2x squared, sure. So then I'll divide each side by 2. So I find that x squared is equal to 32. And how do I solve that? Square root both sides. Now, friends, when I do the square root of both sides, remember I kept telling you, don't worry, make sure you take care of the plus minus. But because it's a length or a width, would we ever have a negative width or length? No. So I get x is equal to the square root of 32. So then I could say, well, we could break that down. 32 is the same thing as 16 times 2. I'm using 16 times 2 and not 4 and 8. 16 is the biggest perfect square. So what's the square root of 16? 4. So I get 4 square root 2. Well, which side did we call x? W or L? W. So this side is 4 root 2, and this side's double that. So if I go 2 times 4 root 2, that would give me 8 root 2. So this side would be 8 root 2 feet, and this side would be 4 root 2 feet. So someone's tumbling down the stairs, end over end. Yeah, y'all missed that before school, when I got here, there was a car parked. If you go out these doors right here, which had the alarm on it, in that little turnaround, there was a car that was parked, like just straight in. And it was a stolen, abandoned car. So there was all these cops that were like, oh, look at this. So kind of fun. Hey, do we have questions about that problem? Does that seem okay? All right, so I would make sure that, I would give you that equation. I mean, I know that you probably generated, it's probably in your head. So let's look at number 2. Problem number 2 says the perimeter of a rectangle is 40 centimeters and the area is 99 square centimeters. Find the dimensions. Okay, hang on. So let's generate ourselves another rectangle, just because I have the shape builder. Okay, so let's see. I know the area of a rectangle is length times width, and I know the perimeter, because I paid attention once in school, was 2 length plus 2 width. So if I call this length and I call this width, there's certain things I know about this, right? So they told us that the perimeter is 40. So I'm going to get 40 equals 2L plus 2W. I feel comfortable about that. And then we know the area is 99, and that's length times width. So those 2 green equations down there, what do you think? What could we do with those? What could we do with those 2 equations? First off, do we know that we have 2 unknowns? We don't know length or width, do we? What do you think? How should we approach this a little more in depth? Huh? Let's see. Can I solve one of the equations for a letter? So I could say that length is equal to 99 over W, or I could say that width equals 99 over L. And all I would have done there is either divide by L or W. Well, that kind of it's a little goofy when we're trying to solve it because that means I'm plugging in like a weird denominator in there. And the denominator being a letter is not always my favorite thing to do. I wonder if we could take this one. Let's get L by itself. Do you feel comfortable with what I did here? If so, what did I do to get there? Yeah, I subtracted 2W. So if I divide everything now by 2, I'm going to get 20 minus W, because I'm reducing it, is equal to L. Well, that seems a little bit more friendly. Seems more friendly than either of these. Agree? All right, so let's think about what we can do here. I have that. So that tells me that's L. All right, so let's modify that equation. So I have 99 equals L times W. If I take that 20 minus W and plug it in, I'm going to get 99 equals 20 minus W times W. Yowzers. What should I do with that? Ooh, this is weird critical thinking. Oh my goodness. What do you think? I don't know. Let's see. That's W. So I'm going to distribute this over, see what happens. 99 equals 20W minus W squared. Let's subtract 99 from both sides, and I'm going to flip the whole thing over. Let's see. I'm going to get negative W squared plus 20W minus 99 equals 0. Ooh. Gross. Stirrup, what are you doing to us? Oh. All right, let's pause there for a minute and reflect. We agree that area equals length times width. We agree, I hope, that perimeter equals 2L plus 2W. I modified what I knew. I could have plugged in 99 over W into the one equation, or I could have plugged 99 over L for W into the other equation. But I decided to solve for L on the perimeter equation. That seemed a little nicer. So what can I do with that? What can I do with this? I wonder, I'm curious. Do you think I can multiply everything here by -1? If I distribute it here, 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 and here. If I do that, I get W squared minus 20W plus 99 equals 0. You see where all the signs just changed? And I think this might be something we could factor. And we could factor it the faster way. So I'm going to go W and W. And that's equal to 0. All right, so think about this. This is going to tell us exactly what to plug in. I want to figure out two numbers I could plug in to multiply to give me positive 99, but add to get me negative 20. So, dude, we're talking 99 here. So it is 1 times 99, 99. And it is 3 And you said 11 and 9? All right. Now, question for you. If I go 9 times 11, I get 99. But if I go 9 plus 11, I get positive 20. So what do you know about the two signs for 9 and 11? Both negative, yeah. So I have negative 9 and negative 11. So I'm going to plug those directly in right here. So what does W have to equal? There's two answers. What's one of the answers? 11. What's the other answer? 11 and 9. All right. You know what? So if I went with, I think that's going to be both. So I have W equals 11, W equals 9. They're both positive. We can have positive lengths. So normally we know the length is the longer. So I'd say that that's 9 centimeters, or 11 centimeters, I'm sorry. And then the width is 9 centimeters. I think that works. Ooh, that's a whole bunch of. I don't know if I'm real pleased with that. But I'm kind of putting some prior knowledge equations in place. I think we can do that. But I think that for a lot of you, there is a lot up there that creates a whole heck of a lot of anxiety all at once. Agree? Cool. So how can we kind of start limiting some of the anxieties? And I'm not quite sure, but we'll try. So being we're dealing with rectangles, we're definitely do you all feel comfortable that area is equal to length times width? You've seen that equation at least once in school. And then that perimeter equation, though you might not remember it, seeing it, you might realize, oh, I have two lengths and I have two widths. If I add all the lengths and all the widths together, I get the distance around. I hope so. All right, let's see if we can play with this a little bit further. It says the area of a rectangle is 36 square feet. The length is one more than twice the width. Oh, what? Now we have land of make-believe grammar. All right. So first thing I'm going to start with. I have length and I have width. Agree? They tell us the area of the rectangle is equal to 36. So I get 36 equals length times width. Okay. So I'm going to call the width x, and they tell us the length is one more than twice the width. Well, we call the width x, so that's twice as, and then one more. Let's give that a little pause. What do you think I could do with the red x and the red 2x plus 1? Yeah, I can multiply. I can just plug in. This can go right here, and this can go right here. So let's see. I have 2x plus 1 times x equals 36. That's the relationship of the area. What can I do from there? Yeah, I like it. Let's distribute that x. I'll get rid of the parentheses. Good idea. Ooh, I got an email. Yay. And this maybe could factor. If I get to that, I want it equal to 0. So if I subtract the 36, all right. So let's see. I guess I could use the quadratic formula on it, but I don't know if I want a c value of negative 36. Let's see if we can find a little easier. So if we were going to factor this, do you agree that if I had 2x in the very first spot and x in the second spot, if I multiplied 2x times x, I'd get 2x squared? Okay, and I'm trying to shortcut this a little bit. So now we have to think about, I have a negative 36 that I have to get to. And the negative 36 comes from multiplying the last terms together. So I know that 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. I don't know if we're going to be able to chase that dog around a tree that way. So let's hold off on this. Let's go back to our regular way of factoring, because that's kind of a guess and check. So I'm just showing you that to realize that there is a way to factor these sometimes a little quicker than doing it the way we had done it. So let's do it the way we have done it, because we've seen this before. I'm going to go negative 36 times 2, and I'm going to get negative 72. In order to get a negative number, I have to have a positive and a negative component to it. And you're thinking 8 and 9 because they're one apart from each other, right? Yeah, so I don't know if we have to list them all. I like that. 8 and 9. If I multiply those together, I'm going to get the 72. One of them has to be negative. So which one has to be negative? So when I add them together, I get to negative 1. Let's see, if I made negative 8 and positive 9, if I added those together, I'd get positive 1. If I flip-flopped it, I'd get negative 1. So this is the method I'm going to use here. So you remember when we're factoring, I brought this down, I got 2x squared. I brought this down, I got minus 36. And then I'm going to make sure I have a positive 8 and a negative 9x, whatever order I want. Does this look familiar? We've seen this before. And it still is equal to 0, which is great. All right, those first two terms, what do I have in common? 2x, very good. If I factor a 2x out of 2x squared, I'm left with x. If I factor a 2x out of 8x, I'm left with a 4. Remember, this sign has to come down. What can I factor out of both of these? 9, I like it. If I factor a negative 9 out of negative 9x, I'm left with x. If I factor a negative 9 out of negative 36, I think it has to be positive 4. All right. So I get x plus 4, and my other one's got to be 2x minus 9. I'm going to set those equal to 0. What do you guarantee about a length every time? It has to be positive or negative. What do you think? Is the length a positive always, or could it be negative? Could I say when we drove home, however you got home, it's always positive distance. Okay, so this first answer is going to be negative 4. So that's not going to work because I'm not going to have a negative width. Okay, so we can eliminate that one. Let's solve the other one. So I get 2x minus 9, so 2x equals 9. So x equals 9 over 2, which I think we could say that is 9 over 2. Come on, Stirp, you can make it 9 better than that. So that's feet. So that's my width. If I take that 9 over 2 and plug it in here, what's going to happen? Those cancel. 9 plus 1 is equal to 10. So that means x is equal to, or the length is equal to 10, and the width is equal, oh, okay, we got it. So that was the length right there. So length is 10 feet. And the width is 9/2 feet, which I guess we could call that 4.5 if we want to make a decimal. That would make more sense in the context. So 4.5 feet with the width, 11 feet for the length. Ooh, this is kind of brutal. This is kind of brutal. But let's hold off on number 4 and 5 for Monday. Okay? And I think in our book we could find a couple of these. Hopefully they're friendlier, but just try it. It's a different way of thinking. So what do we say we try? Give me a try of page 173 in your book and try number 1 and number 2. I'd say some of the things maybe that might make it work. You know that area equals length times width. You might have to use that. Perimeter is equal to 2 length plus 2 width. And maybe you want a rectangle drawn so you know you have a length and a width. But I'd say give those a try, just number 1 and 2. And I bet you get a little bit further than you think. You might not get it all the way, but you might be able to get a little bit further. Bless you. Bless you. What's today's date? Today, the 15th? 4/15 assigned 1 and 2. Cool? All right, I'm going to stop recording now. Give you the opportunity to work on those. You can ask me about it. You can try and work with each other. Yeah. Tuesday, no, and yesterday, no. Yesterday, I just kind of introduced some quadratic word problems. Watched a really bad motorcycle video, but I did